Yes, there is a shift. Yes. Let's wait for the crowd to come. Maybe a few minutes more. Should we start now? Okay.
Thank you everyone for being here that this afternoon. Welcome to us. It's been Turkish.
Selamun Aleyküm. Ladies and gentlemen. My name is Burhan.
Burhan. We're from the company Turkcell. You know Turkcell is the biggest mobile network provider in Turkey. It's like a lot you have in UAE. So they mentioned me and a number. He said they have about 70, 60 million.
70 minutes.
70 million users in Turkcell. And he's the Android guy there. So if there's a bug, I think the disaster for Asian, like 20 million of Android users not be able to use the Android app, right?
Yes.
Because you have 70 million, so like 20 million, the number is astronomical, like 70 million. So happy to see and hear what you're going to say about the Android components.
Thank you, Mohammed. Okay, everybody hear me, right? I don't have to use this because I have two microphones also. Yes, it makes three. Okay, ladies and gentlemen, salam alaikum. When making presentations, you should find new ways to attract people's attention, right? And I discovered that in Arab countries, the best way to do this is just calling them salam alaikum. And then they pay attention to you, and then they say alaikum salam. So today I'm going to talk about architecture components. I've selected this topic because I think it's the most prestigious update of Android world in recent years. That was something that we have waited so long for it, right? But first, let me briefly introduce myself as this is not working because not open. Yes. Okay, as Mohammed has mentioned, my name is Burhan Aras. You can see on the board. And I'm from Istanbul, Turkey. The city with mosque is on Bosphorus. And I'm working for Turkcell. I hope many of you have heard about Turkcell. Turkcell is the largest GSM operator of the Turkey and one of the largest in Europe and Middle East, with its 70 million customers. And Turkcell has a strategy for becoming the first digital operator of the world, so it provides a bunch of apps for making people's life easier. And TV Plus is one of them. I'm working for that product. The TV Plus is basically an IPTV solution. It's a Netflix competitor. You can watch movies, series, and live broadcast of TV channels, etc. You can download it from App Store and Google Play. On Android side, we support 3 devices, phones, tablets, and Android TVs. And we're very keen on using latest technology, so you can imagine how excited we were when Google has announced the architecture components. Because we constantly keep trying to find better ways to build a much better, much robust architecture for our apps and provide a much more crash-free app to our customers, right? And I think that sounds quite familiar to all of you because we are all aware that Android lacks standardization of architecture. So we said Android lacks standardization architecture. At this point, in response to a popular demand, Google's framework team has announced the architecture components. So what is this famous architecture components. Let's look at them one by one and explain them in short, then we will get into details. First of all, LiveData. LiveData is a observer for data. When in our app data changes, we need to be notified in order to update the UI, right? And LiveData basically handles this. Lifecycle is our second component. When LiveData is working, it needs to know the application state. The application is on screen, off screen, or other state. So that brings us to new components such as Lifecycle Owners and Lifecycle Observers. Thanks to Lifecycle, LiveData knows the application status, so it can decide should we update the UI or we shouldn't. And WeModule, this class is gonna replace your presenters in your application if you are using MVP, Model V Presenter. It basically keeps the logic related to UI and hold all the data UI needed. And WeModule survives configuration changes. We will explain this, how it's happening. Last but not least, Room, maybe the most famous one. Room basically maps our entity fields to local database tables and makes persistence in Android super easy. Okay, we said we have Android architecture components, but why do we need it? Why did we wait so long for it? The answer lies with Google. They say on August 2016 they have a meeting with CAP. CAP stands for Customer Advisory Board, and they asked the magic question: what is hard with Android development? What is hard? And I think the answer is quite familiar with all of us, since we are all developers. You don't have to be genius to make a guess what's hard with Android. Let's look at the answers. These are the answers that developers find hard with Android. First of all, life cycles. Developers find it to manage life cycles in Android, and that's quite easy. That's fair enough, I think, because I think life cycle is the strongest part of Android, but also the weakest one. Yes, it provides so many detailed data related to the application life status, but if you don't know how to use them properly, it's gonna crash a lot. Then the architecture. You know, Android receives its initial power from Java world, and Java means freedom. Rockstar developers, lots of frameworks, lots of architectures, patterns, principles. Then we see MVVM, and we're lost again. So it's just fresh starters don't know where to start, and they just don't know how to architect their apps. So architectures is a big problem to be solved, and Android lacks standardization of architecture. Next is persistence. Yes, that's the most scaling part of Android. We all know that. You have to declare all the database fields, all the tables, all the queries, one by one in your SQLite Open Data Helper, and you have to provide implementation for all the CRUD operations. That means that sounds lots of work, lots of boilerplate code, lots of mistakes. Persistence in Android shouldn't be that hard. And the next thing is testing. Okay, I accept testing itself is hard. Most of the time, it's just us who don't know how to test our code. But it's clearly obvious that components in Android are really hard to test, such as activities, fragments, content providers, and services. Unfortunately, Android architecture development, architecture components does not bring any extra ability with testing, but thanks to WeModules, it makes testing UI logic much easier. The other things that developers find hard is navigation, background jobs also, modularity, less boilerplate code. They want to write less boilerplate code, and who doesn't want? And they want security against common errors, etc., etc. So this is the actual access point of Android architecture components. Why do we need architecture components? The reason is that. And now we have a simple diagram. This is a traditional simple Android apps diagram. We have UI, and we have a data source. It connects to a data source. This data source might be a local DB or a cloud. It seems easy, but believe me, it's not as easy as it seems, because in real world, things get complicated. The more components get involved, the more complex it gets. For instance, when developing such a simple app, you have to think about data efficiency. So one possible solution is caching the data in a local DB. But in such a case, you have to think about when to refresh your local DB, right? And and additionally, you have to think about a paging mechanism. Then, what if you have to think about also configuration changes? So, let's assume you make a request to server, and before it responds, just user rotated the devices. What will happen? It's probably gonna crash because you didn't cancel the request on pause. You have to do that. Otherwise, you canceled the request on pause and activity recreated because the device was rotated. You made the same request again. It's going to be a waste of resources. So, on the other hand, we have another picture. This picture demonstrates the architecture that has been proposed by Google. And let's look at them closer. On the top, we have UI components such as activities and fragments. They are all both lifecycle owners. All the UI components are connected to the WeModule. WeModule contains UI-related data in LiveData, and LiveData is lifecycle owner, and WeModule survives configuration changes. Well, that means when user rotate the activity, when user rotate the device, your activity is going to be destroyed and recreated by a framework, right? And that means all the data you stored in activity or fragment is going to be lost. So we use WeModule as a solution to this problem. Then WeModule is connected to a repository. Repository is a pattern. It's a single source of truth for all the app data. It's a clean API for UI to communicate with. And repository may fetch this data from a local DB or a web service or both or maybe none. It's completely up to it. On local DB side, we use Room to persist our data. As I said before, Room just maps our entity fields to local database fields. And it makes persistence in Android very super easy. On the other side, we use Retrofit to connect a remote data source. And Retrofit maybe is the most famous. My microphone not working? Okay. Is it working? Test. Everybody hear me? Okay. Sorry for the problem. Where did we were? Retrofit. Yes, we use Retrofit to connect a web service, and maybe it's the most famous library in Android world, right? That is the picture that Google wants to see in our projects from now on. Okay, let's look at the closer one by one to the architecture components. We said first of all them is lifecycle. Lifecycle helps you solve lifecycle problems. It's basically an abstract class that holds the information related to lifecycle state of UI components, and it brings us to definite components. First of all, lifecycle owner and the lifecycle observer. For an object to be a lifecycle owner, it must implement lifecycle owner interface. And observers must implement lifecycle observer interface. So, but in our activities, thanks to support library 2610, we no longer have to implement lifecycle owner interface for our activities and fragments because app compat activity and the fragment classes themselves, they have implemented lifecycle owner interface for us. Lifecycle owner means that an object who has simply a lifecycle. For instance, on the right side, we see a lifecycle owner. It's an activity, and it has some lifecycle methods: on create, start, resume, pause, stop, and destroy. On the right side, we see another object, which is a lifecycle observer. It's a lifecycle observer because it implements the lifecycle observer interface. It's just a marker interface. It doesn't have any methods in it, but still you have to implement it. And we see some methods in it. All these methods, voice is gone again, I think. Today we're having some problems with voice. Let's wait for a few minutes, maybe. But anyway, don't worry. Let's continue. Let's keep going. Lifecycle observer. Here we have an owner object and an observer object. Then we write methods in our observer classes, and then we annotate them with lifecycle event annotations. For instance, for onCreate method, we annotate our methods with lifecycle event onCreate. What does this mean? That means that if onCreate method of our activity is called, then respectively, the onCreate annotated method of lifecycle observer is going to be triggered. And these are the annotations allowed. Everyone for each term: create, start, resume, pause, stop, destroy. And we have an extra one lifecycle event on any. That means it can be triggered on any activity callback. Let's see an example. We talked about lifecycle observers. This is a simple lifecycle observer. It implements the lifecycle observer interface, but it does not have any methods because it's just marker interface. And we have written any FEV methods, and we have annotated with lifecycle event annotations. That's the simple lifecycle observer. That is all what we can do. On the other side, we have a fragment, which is a lifecycle owner. As I said before. How do we register a lifecycle owner, observer to a lifecycle owner? At first, we just create an instance of our observer object. You can see lifecycle observer. Then, in any of methods, we use just lifecycle.addObserver method, and that is it. From now on, when any of our fragments lifecycle methods are called, the lifecycle object's respective method is going to be triggered. That is so simple, just 2 lines of code. But there is a tricky question here. Which one is called first? What is the calling order? For instance, we said that activities onCreate method is called, then the observers onCreate method is going to be triggered. But what is the order? Do you have any idea?
Depends on the state.
Yes, as written on the slide.
No, I mean, if I am in non-stop, I will
Yes.
like non-stop.
Yes. There is a famous idiom in Android world, and we all know that constructive first, destructive last. That is the same here. On constructive methods, such as create, on start, on resume, the activities or fragments callback methods are triggered first, and then the observers. It's not working yet. And we no longer need it seems. Yes. As I said before, on the constructive methods, lifecycle owner's method is going to be called first, and then the observer method is triggered. But only the destructive methods, such as onPause, onStop, onDestroy, the observer's method is going to be triggered first, and then the activities or the lifecycle owner's method is going to be triggered. So the point behind is that if your activity or fragment is going to be destroyed, you have to know it before it destructs. Yeah? Okay, yet another tricky question is, how did we get lifecycle from activity or fragment? Just 2 slides before. This is a fragment, simple fragment, right? And we just said lifecycle. In Java, we say get lifecycle. In Kotlin, we don't have to do this. Where did this lifecycle object come from? We didn't define it. Any ideas? The simplest solution, because as I've said before, in support library 2610, app-compat activity and the fragment classes itself, they implement lifecycle owner interfaces for us. Okay, what if we don't want to use app-compat activity? Thank you. Everybody hear me right? Okay, again. My volume is too low, too down. Oh, it was down. Okay. I thought that everybody's without microphone, everybody was hearing me, but okay. Let's keep going. We said app-compat activity and fragment classes themselves implement lifecycle owner interfaces for us. But what if we don't want to use app-compat activity? We want our activity to be a lifecycle owner, and we don't want to extend app-compat activity. One possible solution is to extend lifecycle activity class. Other solution is that you yourself implement a lifecycle owner interface. And that is how we are going to do it. And first of all, of course, we implement the Lifecycle Owner interface. Lifecycle Owner interface has only one method to override, get lifecycle. In this get lifecycle method, we return a registry object, lifecycle registry. This class is a simple class, is a special class, comes with Android architecture components library. And then in the all the right, such as on create, on start, you just mark the lifecycle registry with respective state. For instance, on start, you just mark the lifecycle registry with lifecycle state started. And then the lifecycle registry handles all this. Okay. Now, some tricky questions. What method is the best to call observe method? Generally, on create, what is the there is no restriction for this. You can call, or you can observe in any methods. But please don't do it on the destructive callbacks. Then, how to remove a lifecycle observer? You know, we have a lifecycle object has a add observer method which adds the observer, but you don't want to be observed anymore. Then, respectively, it has a remove observer method. You can just remove the observers. Are Android views lifecycle owners such as text fields or buttons? Of course not, because they don't have their own lifecycle and they are not implementing lifecycle owners. And what about custom views? Can we define a custom view which is a lifecycle owner? For instance, a custom text view. Of course we can, because all you have to do is just implement lifecycle owner interface and mark the state in registry. Okay, WeModule, let's pass to WeModule. Things are getting much fun, you're gonna love this class. WeModule was introduced for another lifecycle problems, as I said before. Here we see a WeModule class which implements WeModule, and here's a lifecycle aware component. WeModule keeps the logic related to UI and all the data that UI needs in a lifecycle aware way. So it keeps all the data that UI needed in generics called as live data, and when the live data is changed, any change happens to data, it notifies all the observers, which are the lifecycle owners, activities and fragments. On this picture, we see an activity of fragment, which is a lifecycle owner, and it connects to the WeModule. And when anything changes in the data, it's going to be immediately notified. The question here is, why do we need WeModule? Okay, we know that the Android framework manages the lifecycle of UI components such as activity and fragment. That means that the framework can decide to kill, destroy, and recreate the activity or fragment without of your control. And that means that you lose all the data you store in activity or fragment. WeModule survives configuration changes. If we keep all the data that UI needed in WeModule, that means that when our activity is killed, then it's not going to be a problem. We're not going to lose the data. WeModule was introduced to solve this problem. Another question is, what is the scope? So we said that WeModule survives configuration changes, but how this happens? Here we see on the right side, we see the lifecycle methods of an activity. And in onCreate method, we get a instance of our WeModule. Then the device was rotated, you can see from the methods, and a new activity was created, but the WeModule scope still remains the same. That means on this point, we have another instance of activity, but still the same instance of WeModule. That's how WeModule survives configuration changes. But there is another point. When the activity is finished, WeModule scope ends. As you can see, onClear method is called, where the other possible situations is that you press the back button, your activity is destroyed, and WeModule is also destroyed. But then if your application is removed from background, then your WeModule is going to be cleared again. If a framework decides to kill your application, then your WeModule is going to be destroyed again. WeModule can't survive such situations. Okay, let's see some code. Here here is simple WeModule class. First of all, we of course implement the WeModule. Then we have a data we have stored in mutable LiveData. We just get the list of repos from GitHub, and mutable LiveData is a subclass of LiveData, and it's mutable, as you can infer from the name. It has two methods: get set value and post value. It exposes these two methods publicly. If you are calling LiveData from main thread, then you should use set value. But if you are calling from another thread, you should use post value method. On the constructor initializing, we just initialize our repository, and then we download the repos. We download the data from repo. For brevity, we just didn't provide the code here. And then that's all. This is our WeModule. How to consume it? Okay, this is a simple fragment. First of all, we get an instance of our WeModule. We use WeModule providers class. That's kind of factory class for WeModules. And we give the name of our WeModule class as a parameter. That section is important because that's what makes the magic. That's what makes the WeModule survive the configuration changes. Because if you try to instantiate WeModule with new keyword or its constructor, it's never gonna survive the changes, configuration changes. And then in WeModule, there is a mutable LiveData we call as repos. Then we observe the repos, and we give an observer object to repos as an observer object. Whenever the repos object is changed, we are going to be notified here, and we can update the UI here. That is a simple fragment. It demonstrates how we can consume the WeModule. Okay, there are another benefits of WeModule. First of all, we can share data between fragments, right? On the picture, we see a master fragment and a detailed fragment. For instance, assume a tablet. We have two sections, one list, and the right side is detail. When the user taps on one of the list items, then we want to see the details on the right side, okay? The magic is here that all two different fragments are connected to the same WeModule, and the master fragment observes the list object in WeModule, and the detailed fragment observes the detailed object in LiveData. Let's see some code for this. I have a small demo, but okay. Everybody here sees that. Here we have two different fragments, master fragment and detailed fragment, and we have the share WeModule. Those two fragments are connected to the same WeModule. For instance, this is the master fragment. And you see it connects the shared WeModule. And he observes the repos object. That something changed if the user selects one of the repos, it goes to the WeModule and triggers this select repo method. Let's go to there. What's happening? When one of the repos items is selected, in the WeModule, the repo detail, the detail object is updated. Since in our detail fragment, there is an observer to repos detail object, this is updated instantly. Yet another way of using WeModule. Okay. Okay, what if we are using MVP, Model V Presenter? What we will do, I want to replace my Presenter class with WeModule. Then it's really easy to replace the WePresenter class as WeModule, but most of the case you don't have to. You can still have both of them together all the same time. In such a situation, you can add the WeModule as a new layer between the Presenter class and the repository class. That is just a recommendation. Okay, some tricky questions about WeModule. Does WeModule notify UI when app is off screen? No, it only notifies the app screen on the active state, such as on started and on resumed. If your application on the on pause state, it's not going to be triggered. Should we keep a reference to Weave in modules? No, definitely not, because keeping a reference to a Weave activity fragment or a context object is a serious risk, because your application may gonna crash. Why I'm calling this? Because let's assume that you keep a context in your WeModule, and then you make async call to fetch data. It may take some time to get response from it, and when the response comes, this context may no longer be available. It's going to be crash, of course. WeModule and Android WeModule, what is the difference? We say that do not keep a reference to context in your WeModule, but what if you need a context object? You know, for instance, you want to reach the system services. The solution is just extend the Android WeModule class instead the WeModule. Android WeModule extends WeModule, and in one of its constructors, it has a direct reference to the application context objects. You can safely use it. Okay, LiveData, we have talked about it, but still another yet components. LiveData is an observable data holder class. It's just a generic. You wrap your data and you wait for the observers. If anything changes, any change happens to your data, the observers are going to be notified immediately. Unlike a regular observer, LiveData is lifecycle aware, as we said, that it just only triggers when your application is in active state, on started or on pause, on started on resumed, sorry. And meaning it respects the lifecycle of other components such as activities, fragment services. And this awareness ensures LiveData only updates app component observers that are in the active lifecycle state, as we have said before. The advantages of LiveData, it has so many advantages, but just name one of them, a few of them. Ensures your UIMIs your data state, no memory leaks, as we said before, no crash due to stopped activities, always up-to-date data, proper configuration changes, and sharing resources. Okay, how to work with LiveData? We have seen the code examples, but let's name it again. In WeModule, we just create and LiveData instance. And then in our activity or fragment in UI component, we create an observer project for the data field in WeModule. And then we call the observe method, and we give the observer object as a parameter. Some other questions, without the lifecycle owner, how can we observe? Because we give these object, the lifecycle owner object, as a parameter when we're calling the WeModule providers. Without the lifecycle owner, you can still observe, but you have to use a different method, use observe forever method. And you can also remove the observers using a remove observer method, as we said before. That is a simple LiveData coding example. It just keeps a string in it and initialize it, as we have shown on our code example. And if this current name changes anytime, it notifies the observers. Okay, we can extend LiveData, of course. Android means freedom. You can extend anything which is not final. But this is a simple example how to extend LiveData. It has 3 methods: on active, on inactive, and set value. On active, we said that LiveData is lifecycle aware, so that is why we need those methods, active and inactive. And then you use the set value method to set the change. Okay, there is another component which is mediator LiveData. For instance, you have 2 different LiveData. You use mediator LiveData to merge them. That is how can we sum up in shortest way. Let's quickly pass Room. Okay, Room. We said Room is simply an ORM solution for Android. It makes super easy Android persistence. In Room simply maps our entity fields to local database tables. Room has 3 different components: entities, DAOs, and the database object itself. In entities, we have get, set, field values, and serial, and we may give them some respective new names. And then we have DAO, data access object. It's a very common design pattern. Everybody knows it. It gets empty from the database and persists it. It just completely contain CRUD operations. And then we have the room database, which just interacts with DAO. That is a simple POJO class, and it's now an entity marketed with entity annotation. And then we provide a key, then some column info. We can name the columns using the column info annotation. Most of the ORM solutions, the section is same. What here is the difference? This is our user DAO, and it's only an interface. Most of the times we have to provide implementation to DAOs, but in Room it's not like that. And we can annotate some method. Oops, it's gone too much. What happened? Sorry for the accident. Let's get back it. Yes. Yes. For instance, delete method and insert method, we just annotate them with the respective annotations. And then the first three methods, we can provide SQL queries also. We developers love to provide SQL queries. The Room's first advantage is that it checks the SQL on compile time. For instance, the first SQL query select anything from user. If there is no table in the database called as user, you made a typo, then it's going to notify you on compile time. That is the first advantage of Room. And then how to use the Room. We define just a Room database class, and we define the user DAO in it. It's just an injection. Then this is how we use the Room. It's just a simple line of code. We get the database instance and call the methods of DAO. Yes, we have talked about architecture components. Google has a feedback form for it. We are developers, we are using it, and they care about our opinion. You can click on this URL, and you can just provide your opinion for how to improve it in upcoming versions. And ladies and gentlemen, thank you again for inviting me to here to make a speech to such an audience in such a beautiful country. Special thanks to Mohammed Harastani, who invited me here. Thank you for coming today here and joining our session. As I've said before, my name is Burhan Aras. I came from Istanbul, Turkey. If any of you come to Istanbul, please ping me. Just text me, and we can have a coffee. If you have any questions, of course, we can take it. Please.
My question, because it's a new thing, like new architecture stuff from Madrid.
Yes.
What is your opinion about unit testing this? Like,
yes.
Do you model, for example?
Yes.
Some of those like contains this logic.
Yes.
And the other thing, like about the handling the errors to getting, for instance, databases.
Yes.
Some error can happen.
First of all, testing. As I said before, architecture components do not bring any extra ability for testing, unfortunately, but I hope in future it will. And as you said, WeModule makes it very easy to implement, to test our user interfaces. If you define methods properly in your WeModule, you can test them correctly, because if you follow the instructions from Uncle Bob, he says test must be first repeatedly on time, etc., etc. And if you define your architecture in a much clean way, it's going to be easy to test it, of course. Your second question was?
About handling the errors.
Handling the errors, okay. We said that if LiveData... Yeah. For instance, when calling to the network, if something happens, how do you show the error field? Okay, you define error fields in mutable LiveData, and then if the value is changed, your UI component is going to be notified immediately, automatically. You don't have to do it for it. For instance, you have a string in your WeModule as error message. It's wrapped with mutable LiveData, and your UI components activity of fragment observe to that string. If an error happens, the string is going to be initialized. And whenever it's initialized or its value is changed, then your UI component is going to be triggered automatically.
So your business logic is tied to the somehow to view?
No, your business logic is not tied to view. That is the pros of the advantage of WeModule. You just keep a data in your WeModule class. You don't have any connection with other ones. Whenever it's changed, the other observers are automatically triggered. So you don't have any connection to them. Please.
You said that for custom use, you can also have a lifecycle owner. But custom use do not have one star on
Yes.
top, and the only way to do that before was with huge fee of server, and you have to subscribe to that, and then it's very difficult to know if
Yes.
it is gone or not.
Yes, custom views do not have lifecycle methods like an activity on create, on start, on resume, but they have on layout, on measure, on drop, etc. You don't have respective, you don't have respective annotations for that, but it's completely up to you to implement a lifecycle owner interface. For instance, you have a text field, custom text field class. You implement the lifecycle owner interface. You define a lifecycle registry object on it. On your on-drop methods, you mark the registry with on-create annotation or another one. It's completely up to you. I said that it's technically possible, but it's not recommended.
How do you know that your view is gone? Like, how do you notify your lifecycle owner that I'm not there anymore in a custom view? Because for me, that is very difficult. There's no callback when so you have a custom view, as you said, a counter. Then that counter can be gone or whatever from a tree of views. Where would you put on the lifecycle owner called like on stop?
You mean in WeModule?
Sorry?
You mean in WeModule?
No, custom view.
Okay.
Where do you put the on stop from activity?
So you don't have to put an on stop method. I said a custom view has its own methods, right? On create, on draw, on layout, on measure.
Which one is the one from those that you will recommend to unsubscribe?
I said it's completely up to you. You can mark it, for instance, you can mark the registry as on created with on draw methods. It's completely up to you. I said that it's not recommended, but it's technically possible. Please.
Do you think the view model is the end of Fragment?
No, it's not. It's not for finishing the fragment. It was introduced for working with fragments, I think, as a support.
Because we don't need any more fragments. We need view. View and view
No.
and view.
The difference is that fragments was introduced for different screen sizes Android devices. You implement a part of screen as a component in fragments. You use them whenever it's required. But for every UI component, we have only one WeModule, which keeps the data.
Yeah, I mean, if I make a custom view, I can avoid fragment because custom view will have the view model. I can glue the custom view use lifecycle, and so I can get rid of fragments.
Actually, that depends, but when in complex applications, if you don't use any fragment, it's going to be complicated. It's going to be a God activity object. It still has some risks. I don't think it's going to remove the fragments. Vice versa, it's for supplying it, I think, supporting the fragments. Any other questions? Please.
On the live data, one thing I noticed is that when I use it,
Yes.
the live data notification will come whether or not your result set has changed or not. I was wondering if anyone had done any performance testing that's making it rerun the query every single update that comes to that.
Actually, there is no official information about how quickly it works, but according to Google, it works well. You're welcome. Any other questions? It seems that there is no other question. Ladies and gentlemen, thank you very much, and thank you again. Thank you again, Mohammed.
Thank you so much, Burhan. Thank you for having me here. We come